Okay. Hello, everyone. My name is Xingang Li, and I'm a PhD student from Dr. Sha's group. And my research interest is focused on AI-assisted design method. So I'm trying to use some deep learning method and like generative design method to try to quickly connect the designer's design idea to the manufacturing. So today my topic is related to one of our recent research, and it is from 2D sketching to 3D printing, deep learning approach for 3D mesh generation with 2D sketches. So today my topic might kind of shift your focus from the manufacturing to the design part. Yeah. So our research started from the observation of a typical engineering design process, and which could be very iterative, especially in the very early. Maybe I need to. Yeah, sorry about that. So especially in the early design stages, the engineering design process could be very iterative. And in many cases, 2D sketching is used in the conceptual design phase to brainstorm design ideas and generate new design concepts. So later on, the 3D models will be created for like rapid prototyping and engineering analysis. However, the 3D modeling is very, very time consuming. Here, I use a blue area and black points to represent the design space and the design concepts. You know, under very limited development time, only a few design concepts can be created, and only a portion of them can be further 3D modeled, prototyped, and tested. So our research question is that, can we automate the 3D modeling process to expedite the design process? And can we generate more design concepts to facilitate the design space exploration? So our research objective is to build a deep learning approach, which could be both predictive and generative to support quicker and more thorough design space exploration to support the design decision of designers. So the predictive function could allow the prediction of a 3D shape from a simple 2D sketch, and the generative function can generate a lot of novel 3D shapes. And also the resulting 3D shape should also be 3D printable, so that user can quickly try their new designs. And here we select the mesh as the 3D representation because it can be directly 3D printable, and also it has good surface quality. So instead of using point clouds and voxels. So this is an overview of our method. And to tackle the challenge of predict 3D shape from a 2D sketch, we introduced an intermediate primitive 3D shape as shown in this red rectangle. And actually, we by using this way, we transfer the 2D to 3D prediction to a 3D to 3D prediction problem. And also considering integrating the generative function into this method, we propose target embedding variational autoencoder method, and we call it TEVE for short. And following the structure of this TEVE, we built a E2D network, which has two encoders, encoder 1 and encoder 2, and one decoder here. So we use the case study of the car body design to demonstrate our method. And we need to train this neural network, we need to prepare training data of source shapes and target shapes. So here's the process that we use to prepare our training data pairs. As you can see, starting from the red star, which is the original authentic model, and we first extract its contour here, and then we extrude the contour to the 3D extruded shape. Then the original 3D shape and the extruded 3D shape form one data pair, and we call them target shape and source shape respectively. And this process is done for all 3D shapes that we got in the open source data set. And during training, we divide them to training set and testing set. So here are some results. When the E2D network is trained, we connect the encoder 2 and the decoder to form the predictive network. So here are some results from this network. As you can see here, we can predict an authentic 3D shape from a simple 2D contour sketch. And the resulting 3D shapes can be directly prototyped using a 3D printer. Similarly, we can connect the encoder 1 and the decoder 2 to form a generative network. And given any two different shapes as the starting shape and the ending shape here, we can get their in transition shapes, in between transition shapes using shape interpolation. And we can also randomly generate lots of novel shapes using random generation. Let's come back to the figure that I showed previously. To answer the first question, we replaced the time-consuming 3D modeling process to a 2D to 3D predictive function, so that the design concepts can be more quickly 3D modeled, prototype, and tested. And also, we use the generative function to create more design concepts for the designer, so the design space can be better explored. So which answer the second question. So in conclusion, we propose a method that could be both predictive and generative, and which can connect can quickly connect the idea generation to the prototyping and testing, and which can also allow more thorough design space exploration. We still have some limitations in the current method, because the current method can only deal with the genus 0 topology shapes, and in the future we try to include like topology optimization with deep generative models to generate more complex shapes. And also we observe that the current generative design method, they generate some structure that kind of organic. On one hand, this is good because people can, or designers cannot think of any of those structures. But on the other hand, those structures are usually counterintuitive to human aesthetic or physiology side. So we try to solve those aspects in our future work. And also for the current work, because the generative 3D shape might not be exactly the same as designers imagine in their minds. So we would like to develop a user interface to allow the input of 2D sketches and the modification of the generative 3D shapes. Yeah, we would like to thank the financial support from NLS, and also thank you all for attending this symposium. Yeah, thank you.